Hello, everyone. Thank you all for joining us today. I'm Katie Johns, Managing Editor of Stormwater Solutions. On behalf of SWS and our sponsor, AQUALIS, I'd like to welcome you to today's presentation titled Complex Approach to Stormwater Retrofits. We're going to get started in just a couple of minutes, but first, a little housekeeping. You will notice on your viewer that you have the ability to ask questions. We encourage you to do so, and we'll try to answer as many as we can at the end of the presentation. Any questions we do not get to, we will answer offline. Your speaker today is Erin Zaske. Erin is the Chief Development Officer and a certified stormwater SCM inspection and maintenance professional for the leading stormwater and lift station management provider in the United States and Puerto Rico. As the corporate development leader for AQUALIS, Erin seeks to increase stormwater and wastewater awareness amongst property owners, provide innovative services and solutions to maintain existing water management assets, address aging infrastructure, and disrupt the stormwater and wastewater market with new emerging technology offerings. Erin has more than 15 years of business and brand development experience in the stormwater, sanitary, construction, and manufacturing industries. She also serves on the board of directors for Storm Sensor, a monitoring technology that tracks the effects of climate change and reduces the vulnerability of community stormwater and wastewater infrastructure. And with that, I will turn it over to Erin.
Thank you, Katie. Good afternoon or good morning, everyone, wherever you may be. Thank you for joining me today to discuss stormwater retrofits. We have done a couple of these in our series. It was rehabilitations back in December, and this presentation is going to be about retrofits today. So during today's webinar, we are going to explore the benefits of retrofit applications to existing stormwater control measures, or SCMs, and their importance in addressing aging infrastructure and expansion of urban development. Please note that you will also hear me reference SCMs as BMPs throughout this presentation, in which they're commonly referred to. Next, we will define projects that meet the parameters of retrofits, as well as what deficiencies can be addressed when considering a retrofit or post-construction stormwater control measures. We will then review the methodology and standards that classify the projects under retrofits, from the design and engineering phases to the execution of the retrofit. And lastly, we will look at real-world case studies of retrofits that have solved deficiencies and enhanced water quality measures for the local watershed. Before we start into the basics of retrofit, I would like to discuss the distinction between stormwater repair, rehabilitation, and retrofits, as well as preventative maintenance. Therefore, we will start by reviewing key repair rehabilitation concepts, when they are required, how these differ from a retrofit project, and the expertise needed to enact each phase of the project. Preventative maintenance is necessary to ensure proper stormwater system functionality, while mitigating the chance that property owners will need to repair or rehab their stormwater system. Routine maintenance will also ensure accessibility and regulatory compliance while meeting water quantity and quality requirements. A full assessment of a system's design should be implemented monthly, quarterly, or annually, depending on regulatory compliance as well as geographical implications. Comparably, corrective maintenance is additional action taken before a system failure to prevent potential repair or intensive rehabilitation in the future. This type of maintenance is typically beyond a current system's preventative maintenance plan and will require an out-of-scope proposal to correct the identified deficiencies. If a stormwater system is not properly maintained, it may require repairs or rehabilitation. A repair is usually due to a localized system failure or issue that requires out-of-scope planning and preparation to rectify. Based on damage severity, aging of the system's infrastructure, and frequency of component or system failure, a cleaning, patching, repavement, or component replacement may take place. Conversely, a rehabilitation occurs at a system with a large-scale non-compliance issue, deficiency, or failure. A rehabilitation is most often needed when a system lacks proper maintenance over an extended period that results in improper functionality and operational deficiencies. Identifying the need for rehabilitation starts with a system inspection to address its current state and functionality. During this inspection, multiple repair requirements and new conditions may be assessed. If a rehabilitation is recommended, it can include a large-scale system reconstruction, which consists of debris, vegetation, or vector removal, runoff redirection, or vector, jetting, and wastewater pumping. Maintenance, as well as repair and rehabilitation, should be a collaborative approach carried in conjunction with a certified stormwater professional. Professionals understand the engineering, regulatory, and ecological issues impacting stormwater systems and can tailor solutions based on this criteria. In addition, stormwater professionals will work with property owners to create, enact, and ensure a preventative maintenance program that meets the needs of your SCMs and complies with federal, state, and local regulations. If repairs or rehabilitation is needed, stormwater professionals will utilize a comprehensive and innovative approach to restore and maintain system functionality and uphold O&M agreement protocols. Now that we have reviewed the key facets of repair and rehabilitation initiatives for stormwater systems, let's dive into the basics of what a stormwater retrofit is and the phases of retrofit and what impacts these types of projects. A stormwater retrofit can take two paths: installing stormwater best practice management, or BMPs, in locations where they have not been previously implemented, or small-scale changes or redesigns to a part or parts of a stormwater system are made to allow for the installation of new, optimized water quality, runoff reduction, filtration, or retention capabilities. Because retrofitting is a completely custom, one-off solution, the project must take into account several key aspects before a project is approved and a new design is implemented. As always, project and material costs play a large role in the extent of the retrofit and what can be accomplished. But geography-specific aspects, such as the availability of land to increase the size of or add the system, coupled with elevation, soil quality, and local terrain, play a large role in what type of retrofit can be achieved. To implement a retrofit, a project involves a series of actions necessary to ensure approval, intended functionality, and geographic impact. First, property owners will need to work with engineers to provide system studies that ensure the system's new intended capacity and drawdown meet design function for approval. Second, engineers will produce new, municipally approved plans. Once these plans are approved, a retrofit can be executed. In this next section, we will cover key considerations for retrofits, situations in which a retrofit project is necessary for a stormwater system, and real-life case studies where retrofits were implemented. Retrofitting is commonly utilized to solve or mitigate flooding issues within a watershed. This is due in part to prior design deficiencies built into the original system or degradation in the system's intended performance. Geography factors heavily into the frequency and impact of flooding. Areas that are impervious in nature, such as parking lots and paved roads, cause stormwater to accumulate and run off. This is due to stormwater failing to infiltrate the surface, which results in the displaced water flowing over roads, parking lots, and other impervious infrastructure until it collects and stagnates in a low-lying area. While the system itself and its location factor in how or why flooding may occur, climate change can determine when a system may flood. In warm climates, flooding typically occurs most often during the rainy season, as stormwater runoff accumulates at a greater rate and displaced. However, we are seeing, due to climate change, the frequency of these increase significantly. In colder climates, flooding frequently follows the spring snowmelt, As temperatures rise and runoff from the mass accumulation of snowmelt flows into nearby drainage systems and bodies of water, overflowing the area. This type of flooding can also include a high concentration of pollutants, sediment, and debris that are harmful for stormwater systems and the surrounding area. Increases in extreme weather events are prevalent across the nation, including significant flooding in certain geographies. But what are the key impacts as it has on the surrounding stormwater assets? For a stormwater system, flooding can result in a number of cause failures, including clogged catch basins, cracked piping, vegetation destruction, and drainage issues. Infrastructure surrounding the system is also at risk. Structure degradation and cracking can occur, as well as water seepage into surrounding buildings and undesirable locations. If damaged systems are left too long without repair, dangerous sinkholes can occur due to a subsurface erosion of foundational soil and sediment. Sinkholes are a critical safety threat and can lead to irreparable damage and bodily harm to residents and passersby. Safety risks are not exclusive to sinkhole formation either. Flooding itself can create a substantial risk of hydroplaning, car accidents, bodily harm due to falls, breeding of dangerous mold, and electrocution from exposed wires caused by flooding or debris. Suffice it to say that if a system isn't functioning properly, or there is damage to it or the surrounding area due to flooding, property owners are at risk of receiving a notice of violation, or NOV. These are corrective orders and fines that local municipalities issue to property owners when their system does not meet compliance standards for operation. If a system is non-compliant, it is the responsibility of property owners to take corrective action to repair their system and restore it to compliance. Failure to do so can result in severe fines, sometimes daily, in addition to costly repairs needed to bring the system back to functionality. Many times, retrofits are necessary to modernize existing systems when the volume of water increases due to growth in an urbanized area, which causes flooding. In Covington, Louisiana, a parking lot owned by a retail chain required a retrofit for this exact reason. A surplus of impervious material and an increase in stormwater runoff led to frequent bouts of flooding, which you can see on the photo in the next slide. AQUALIS provided a precise retrofit solution which within strict municipal parameters to remove, replace, and regrade pavement, sidewalks, and curbs. AQUALIS also installed an off-site concrete swale and dissipator to divert runoff, while adding an upstream vegetative buffer. Mitigating the serious effects of flooding starts with operationally efficient and geographically tailored stormwater system solutions. While stormwater systems are engineered and built to remove water from impervious surfaces and release it downstream, a stormwater system retrofit may be necessary for systems that flood frequently or have inadequate drainage. Retrofitting an existing system involves adding vegetation, porous soils and substrates, permeable pavements, and temporary storage tanks to improve water infiltration and slow stormwater runoff to prevent overflow and stagnant water. Retrofitting can also be invoked to quell the impacts from erosion within and around the stormwater system. Erosion typically occurs in stormwater systems that have insufficient water volume capacity that causes the system to overflow or flood. It also occurs in improperly managed vegetation, leading to poor filtration and those sites that have a lack of routine maintenance. Erosion can cause a series of cascading and critical impacts for both the system itself and the surrounding locale. As a result of soil disruption, displacement, and sedimentation caused by erosion, natural landscapes and areas near a compromised stormwater system may experience destabilization, sinkhole formation, or a complete unsightly alteration. Water quality is also heavily impacted as the presence of erosion is known to bring suspended solids in water, as well as lead to high water turbidity. The presence of erosion in a stormwater system or surrounding area has a few telltale signs that signal immediate action to property owners. Terrain-wise, the formation of indentations or noticeable paths in which water has broken down soil or sediment is a key indicator that erosion has taken place. Property owners may also observe noticeable soil loss or steep drop-offs. Additionally, their property owners may also observe visual changes to water in and around the area. If water is cloudy, hazy, or filled with solids, corrective action will need to be taken. A stormwater retrofit to mitigate erosion highlights stabilization, proper filtration, and proper filtration management. A retrofit will typically include adding vegetation, manufactured fabrics, and porous surfaces to slow water movement, promote manageable infiltration, and stabilize soil, which ensures indentation and drop-offs do not occur. When retrofitting and installing control measures, actively planning for a sediment regime and unintended effects of stormwater system functions can go a long way in mitigating channel erosion. If sedimentation is allowed to occur, a retrofit may be necessary to stabilize the stormwater system and restore proper functionality. In Lawrenceville, Georgia, a site owned by a hotel chain was not fully converted nor maintained by the developer. This resulted in sedimentation taking place in the forebay, causing destabilized soil in and surrounding the dry pond. Vegetation was also improperly managed, hindering proper filtration of pollutants and sediment. As beneficial vegetation died out, invasive vegetation took root. To retrofit the system, restore adequate function, and mitigate increased runoff and sedimentation, AQUALIS conducted an existing site condition survey to confirm the existing design in relation to the original certified design. They then completed a retrofit of the system by removing sediment and installing a new detention orifice to benefit system drainage efficiency. Additionally, they refreshed and installed riprap while dewatering the system. When considering retrofitting a stormwater system, it is important to install stormwater control measures that not only mitigate risk and the threat of damages, but also promote sustainability for the surrounding environment. Traditionally, systems were designed to channel stormwater away from properties and infrastructure, with an emphasis on engineered systems built with concrete to achieve this goal. This is known as gray stormwater infrastructure and is exemplified by the use of levees, reservoirs, and stormwater drainage systems. Recently, however, a more conservational and environmentally sound SCM called green stormwater infrastructure has been coined and added to traditional gray stormwater systems to promote sustainability. Green stormwater infrastructure centers on mimicking natural hydrological processes to retain, transfer, filter, and drain water. To do so, green stormwater infrastructure utilizes and implements vegetation, porous soils and substrates, permeable pavements, and temporary storage tanks. Green stormwater infrastructure imparts several key benefits for property owners and the surrounding environment. As mentioned earlier, flooding can cause catastrophic impacts for both the stormwater system and property owner. This SCM reduces peak volume during rain events, increases filtration into soils, and expands system volume capabilities, mitigating the risk of flooding. Because green stormwater infrastructure is biofueled and involves the increased use of plants to mirror the hydrological cycle, less energy is used to regulate temperature, and water retention can reduce the need for potable water for industrial or landscaping facets. This, added with reduced gray operational expenses, provides large cost savings for property owners who integrate this SCM approach. Aesthetically, the use of plants and greenery benefits the surrounding area, while making the system more pleasing to the eye. Functionally, these plants help to filter pollutants and sediment from stormwater runoff, enhancing water quality and removing a good amount of pollutant from the locale. In our next section, we're going to be discussing a number of commonly implemented stormwater retrofit projects, use cases, and benefits for property owners. A simple yet highly effective retrofit deals with swapping out impervious pavement or surfaces with porous options. Impervious pavement prevents water from infiltrating the surface beneath and instead diverts it as runoff through and out of the system. This type of surface or pavement makes up a large percentage of urban infrastructure within the United States, with parking lots and roads largely constructed with impervious material. Porous, otherwise known as pervious pavement, allows water to infiltrate the soil beneath the structure. This helps filter the water naturally and decreases the ability for pollutants to be carried to larger bodies of water as runoff. While impervious pavement may currently make up the majority of roads and parking lots, it imparts several challenges for property owners and the surrounding area. Due to water being unable to filter into the surface below, this pavement enables standing water that can lead to drainage issues, flooding, system deterioration, and pollution runoff that makes its way into aquifers and seeps into groundwater when displaced. Retrofitting a stormwater system with pervious pavement reduces standing water and prevents common drainage issues. This is due to the pavement enabling water to travel naturally, which allows the water table to recharge and gradually helps water to dissipate and filter through the soil underneath the pavement. This also prevents sediment and pollution runoff. In many cases, property owners will seek to convert a dry pond to a wet pond based on past performance and the surrounding terrain. A dry pond is primarily designed to hold and discharge water from rainfall events, but remain dry in between. These ponds will typically hold water for 48 to 72 hours before being discharged. Conversely, a wet pond is designed to hold water permanently while releasing captured water over 2 to 5 days via an outlet structure. While dry ponds can filter and remove sediments and pollutants, wet ponds have added vegetation to enhance water filtration and boost hydrological processes in the surrounding ecosystem. Converting a dry pond to a wet pond is one of the most common retrofits seen today. Dry ponds, while easy to maintain and build, are found to be largely inefficient for many property owners, with a large list of negative impacts. Typically, dry ponds have a high water table that decreases the effectiveness of both filtration and drainage. This leads to dry ponds overflowing after rain events and flooding the surrounding areas. Retrofitting a dry pond will focus on resizing a pond while adding capacity and converting the pond to a retention pond to handle an increase in runoff and water storage or to mitigate overflow. As part of the retrofit, vegetation can be added to enhance pollution and sediment removal, along with a sediment forebay. Basins are another stormwater system that may require retrofits to optimize system function. These are typically larger divots with grass as the primary vegetation used for filtration. Stormwater detention basins are built to collect and divert runoff from the surrounding area and channel it into a nearby body of water. They are designed to retain and reduce water from peak rain events while managing water from more frequent, lesser rainfall. Basins are known to lack proper sediment and pollution filtration. They are also inefficient at discharging stormwater runoff from smaller, more frequent rainstorms, which results in sedimentation, erosion, water pollution, and flooding. Retrofitting a basin involves adding vegetation to increase filtration, efficiency, and water retention, as well as adding infiltration measures to better manage and retain runoff. An environmentally conscious and beneficial approach to create a sustainable stormwater system is installing a green roof. I did see a question come in around what examples of green retrofits are, and this is one of them. A green roof is a thin structure that partially or fully covers an area located on the roof of a building, either suspended or as part of the actual structure. They contain a layered system of plants, drained membranes, and tapered insulation that transforms an impermeable surface into a porous surface. Retrofitting a system to include a green roof offers a number of key benefits brought about by weather and drought-tolerant plants, allowing for nourishment of roof vegetation. Green roofs support absorption of stormwater versus running off the impervious roof structure and directly impacting the stormwater system, significantly reducing the volume of stormwater exiting the developed site. Because stormwater is absorbed and discharged at a slower rate, drainage systems are left with a lighter workload, benefiting system functionality and longevity. This also allows for the filtering and proper discharging of carbon dioxide, pollutants, and nitrates. Green roofs are also very low maintenance, as they are known to be highly self-sustaining while imparting energy savings on the local weather patterns and decreasing stormwater utility fees due to lesser workload. There are a number of additional sustainable benefits of retrofitting your existing flat roof with a green roof, including site energy savings, reduction of greenhouse gas emissions, and reducing the urban heat island effect. I don't have a slide for it in here, but another option for a retrofit, which can be used on green roofs as well as in stormwater ponds, is pollinator gardens. Oftentimes you can fence these off, get local plants that are local to the geography, that are pollinator plants that support our pollinating insects, including bees and butterflies, which AQUALIS has done a number of across the country with our customers and partners. So I just want to jump into a little bit about AQUALIS. We are a nationwide leader in post-construction stormwater and lift station management. Our stormwater services are nationwide as well as in Puerto Rico. And in the last year, we have performed nearly 6,500 repairs and retrofits on stormwater assets. As all of you watching or listening to this webinar know, water compliance is not optional. We have crews located across the country and in Puerto Rico to support both stormwater and wastewater preventative maintenance so that we can work with our clients as well as regulatory officials to safeguard property and keep them compliant. At AQUALIS, our stormwater professionals work to help our clients avoid costly violations, reduce liability, improve system performance, and promote stringent site safety through maintenance and corrective repairs. Additionally, you can see our extensive certification for expert services that we have throughout the country. And I went through this much too quickly today, so I am actually through with my presentation, and we can jump into questions.
Thanks so much, Erin. We do have a couple questions. So the first one I will start off with is, how can property owners around the United States, or how are property owners around the United States moving from gray infrastructure to green initiatives, and how does that vary by geography?
Yep. So we actually have a number of clients who are looking for this transition right now. So, green roofs are a great option. We're seeing a lot of that throughout the Midwest. In the Chicago area, we're seeing quite a bit of it, as well as in Michigan and Indiana. We are seeing a lot of pervious pavement in the parking lot. It is a pain to maintain when you switch from impervious to pervious, because typically parking lots are used to the street sweepers coming in, and those oftentimes jumble up the pervious pavement, but there are different ways to maintain that. It is a great option to start moving into green infrastructure as a whole. And then we're seeing some of the I lived in Houston for a long time, and if you think of the bayous, the stormwater bayous that go through Houston, they were just a lot of concrete. And Houston has done a lot of work to turn those into green assets. So still have, the concrete at the way bottom, but they've now taken out some of the concrete, made vegetative slopes there, introduced biking and running paths. So there are a number of ways that you can move from gray infrastructure to green.
Okay, and you did touch on this a little bit, but can you expand on examples of green infrastructure in a desert landscape?
Sure. So, a lot of those where you have, again, the dry ponds, we're seeing more of a change over into the wet ponds and adding vegetation as well, right? So in the desert areas, you have a lot of concrete, and the vegetation is quite different. So the stormwater assets oftentimes look like landscaped assets. So you will have a bed of rocks with vegetation in them, whether it's large trees, cacti, whatever it is. Those are often actually stormwater assets, and use the pervious vegetation for stormwater runoff, and it's captured underground.
Okay. And then another question we have, where are dry pond and wet pond retrofits most often seen in the U.S.?
So it's changing with climate change. We're seeing it more frequently moving into the northern part of the country. We do see a lot more ponds in the southeast, as well as Texas, Louisiana, kind of the area that has moisture all year long. But as we continue to see the change in weather patterns, oftentimes the dry ponds are being impacted more frequently, and that need to retrofit to the wet pond is occurring. So that's when you want to, work with your stormwater management company, talk through. You're going to get a notice of violation from the city if your dry pond is holding water. And if it's something that, can't be fixed with a quick repair or rehabilitation, it means that conversion needs to happen.
Okay. Well, it looks like those are all of the questions that have come in. So we can go ahead and wrap. Oh, we did get one more. Hold on. This question says, additional increases in initial and operating costs for going to green roofs and pervious pavement. How is a roof repaired if it leaks and it is a green roof?
Sorry, let me look at that last part of the
Sure.
roof repaired as it leaks in. So it's going to depend on, oftentimes you're going to hear commentary about green roofs leading to roof leaks, right? What you need to be sure of is to work with the building engineer to make sure that the proper load is available for a green roof to be installed, and that insulation occurs so that you can lessen the potential for those leaks to happen. If they do, occur, then you're going to have to call in, probably your stormwater expert as well as your general contractor to work through what those issues are.
Okay. And we had another one come in. What are the most common retrofits that AQUALIS deals with?
We are in all kinds of them, right? So as everyone knows, there is no common stormwater system. Everything is very unique depending on where you're located. We have done a number of green roofs. We have done a number of retrofits from impervious pavement to pervious. The most common that we see, just in North Carolina, we are everywhere, is that conversion from dry pond to wet pond. But like I said, some other options for green infrastructure is introducing pollinator gardens. So we have done that both in the ponds or, near the store or on top of the store. In the different geographies, we've started kind of our trial out in Washington State. And since we have grown that across the country, so that's an exciting opportunity and something that's, very easy. As long as you can get your irrigation system to help with watering the plants, it's a great opportunity and great PR opportunity for individual property owners.
Great. And then do you have any specific long-term cost savings related to a retrofit, such as lack of mowing, maintenance, et cetera?
So, we see a number of things. Oftentimes, we see property owners who, when they've, taken over a property, oftentimes that stormwater asset has been neglected. And so, it's important that a preventative maintenance plan is implemented right away, because what that maintenance program can allow for is when the crews are out there taking care of the maintenance, they're also identifying any deficiencies. So if they see a safety hazard or a compliance issue or something like a crack in a catch basin that could eventually turn into a large sinkhole, the crews are identifying it right away and can get it back to the property owner so that the proper solution is done in a time frame that allows for it to not turn into a large solution. We've seen, anywhere from a small catch basin turning into a large sinkhole that has to be blocked off, and multiple other examples of that. So it's just very important. I know that there's sometimes pushback or reluctance to want to spend the money to maintain stormwater assets. Quite honestly, it can come out of your landscaping budget and reallocate it to a stormwater provider, because it's just going to save you long term.
Okay. Well, it looks like that was the last of the questions, so we can go ahead and wrap up here. So, Erin, thank you so much for being our speaker today. If any, other questions come in, we can get to those offline. But on behalf of Stormwater Solutions and our sponsor, AQUALIS, I would like to thank you all for your participation today and for staying engaged. This webinar will soon be archived to the same URL you used today. It can be viewed on demand, so you can share it with others. And with that, that's a wrap. So stay informed and stay well, everyone.